Alright, so this is the sketch that will illustrate what was happening as far as how we found the tangent line limit. So I'm going to go ahead and plot the point and make my tangent line. So there's the point and the tangent line. Let me move this over to 1. So the whole process behind finding the limit is, if you can imagine, you have one point for sure on the function. That's where the tangent line is going to be. And you're going to make a second point on the function. This is what, and then draw a red line through those 2 points. And the distance between those 2 points is going to be determined by h. So in this example, 1 was where I started. I'm letting h equal 2. So my other point is going to be 1 plus 2, which is 3. And that's why it's graphed over here at 3. Now I can find the slope through 2 points, like you did in Algebra 1 and Algebra 2 with the whole, y2 minus y1 divided by x2 minus x1. So I'm finding the slope through these 2 points, and my slope between these two points is going to be 2. Now 2 is a very bad approximation to this blue line. So this red line is a bad approximation to the blue tangent line. So a way that you can make this maybe a better approximation, instead of letting h be 2, you want to let maybe h only equal 1. So now you've made the second point closer to the first point. And now you can see that the slope has changed, and that this red line is a little more closely resembling what the blue line is going to be. And the whole idea is that, well, since h represents the distance between the first and the second point, meaning how far these two are apart, why don't I just make h as close as to 0 as possible? Well, I can't let h equal 0, but if you notice, let me go ahead and back this up and move this a little bit slower. As h gets closer and closer to 0, the red line turns into the blue tangent line. And not only that, but if you notice the value of the slope, it seems to be approaching a limit. And that limit that it approaches is the answer we got for the tangent slope.